Hi, I'm Florian. I'm the product group director of the video analytics group at Janatech. In video analytics, we analyze video surveillance videos automatically in order to gather insight. And one of the technologies that we're increasingly using is called deep learning. And in this video, I'm going to give you an in-depth look at how deep learning actually works. There have been many buzzwords around in the market: AI, machine learning, deep learning. And if you're not from the field, it can be very confusing. So I want to clear that up. AI, or artificial intelligence, this idea has been around since the 40s, and it's very broad. It essentially means any kind of system that can sense the world and act upon it in some kind of way. Today, that might be an automatic lawnmower, but it might also be a very complicated AI that reasons by itself. And one of the technologies you can use to sense the world is called machine learning. Machine learning means that it's some kind of system that you train to detect certain things. So you give it a lot of data and it learns how to detect certain things that you train it on. This is called machine learning. And the part of machine learning that seems to work very well is called deep learning. Deep learning has been around since the 60s from an idea perspective, but it was never feasible to do because it relies on the idea that you need vast amounts of data to train this deep network. And this was never really possible until 2012. There was a breakthrough where for the first time someone found a method to do it very efficiently, and at the same time the hardware became more powerful to actually do it. So this really started off the deep learning boom that we see right now. And now I'm going to show you how training a deep learning network actually works. So let's take a closer look on how to train a deep learning neural network. The first thing you need is a large data set. A data set in our space, in the video space, basically means hundreds of thousands and even millions of images that are annotated. And that means for each image, there has to be the information what is on the image, depending on what we want to train the network on. So let's say we want to train a network to detect persons and vehicles or something else. So that would mean we need 1 million images where someone manually tagged the images and said, in this image there's a person, in this image there is a vehicle. And this is a lot of work. And this is also why data sets are the real value, the real gold in the deep learning space. Not so much the algorithms themselves, but the data sets. This is the important thing. So let's start off and say we want to detect persons or vehicles. As I said, we need a data set first. So this here is our data set. Those are 1 million images of persons and vehicles. For each image, we know what is a person, what is a vehicle. Person, vehicle, vehicle. Now we split this data set into two, into a training set and a so-called validation set. So we have 500,000 images in the training set, 500,000 images for the validation set that we need later on in order to verify that what we trained the neural network on really works and how accurate we are. So this is our training set. And this is our validation set. So in this training set, we have 500,000 images. And now we use this data set to train our neural network. Our neural network is called like that because it consists of many nodes, or many layers as we call them, that before it is trained, it's basically blank and all the nodes have the same value. But when we feed it with data, we train the network basically how to characterize persons and how to characterize vehicles. And that's a little bit different in deep learning how it was traditionally done in machine learning. Because traditionally in machine learning, you would choose beforehand what basically best describes a person, what best describes a vehicle. We call it features. So for a person, maybe we would have defined, okay, you have to look for the outline of a person. Maybe it has 2 arms and 2 legs. For a vehicle, it might be the shape of the vehicle. It might be that it has 4 tires. It might be a color of the vehicle and so on. So we would have to define it before. With deep learning, we do not define it before. So we do not know what the best way is to describe a person or a vehicle. But instead, we feed it so much data to the network that eventually it will figure it out by itself. And this is what happens when we train the neural network with our training set. So now we have done that. This training can last for quite a while. Typically, it's maybe in a day, it can be 2 days, it can be 3 days, but it can take quite a while on a very powerful server. But it's important to note that this is really done during the production of the system when we manufacture a new product. So this is done in the lab. This is not done on the fly. And this is a common misconception. Many people think that the deep learning system learns while you deploy it. So you put a camera somewhere, then it learns for a few weeks what persons and vehicles are. No, this is not how it works. You're doing that in the lab with your data set. You're training your neural network. It might take a day, might take 2 days. But what comes out is a final trained network that you put in your product and that is shipped. And once it's shipped, once it is in the product, it just detects persons and vehicles automatically. There's no reason and no necessity to train it on the fly. So now we have a trained neural network, and now we want to know, did we do a good job? Was 500 images, 500,000 images, was it enough to train our neural network? And this is why we have our validation set, which is also 500,000 images, as we chose it before. And we use that now to validate our trained neural network. So we feed this validation set into our trained neural network, and what comes out is essentially an accuracy. So it will tell, well, for so many images it classified them right, for so many images it classified them wrong, because for each image we know, is this a person or is this a vehicle? And this gives us a very good idea how accurate it will be in real life when we actually deploy it for scenes where we do not know what the outcome is. So the accuracy might be maybe 70%, maybe 80%, maybe 90%, maybe 99%. Can go very high, but it really depends on your applications. For some applications, you do not need such a high accuracy. For some, you need a very high accuracy. So once we've validated that, and we know what it does, and we are satisfied with the results, we have a trained neural network. If we want to make it better, we go back, we create more data, we feed it more data to make it better. But once we're satisfied with the result, we have a trained neural network that we can use in our product.